Welcome to a lesson on multiplying radical expressions and adding radical expressions. This is a necessary skill not only for Algebra 2 but also for geometry and pre-calc. We're going to start off with an example of multiplying with radicals, or in this case with square roots. So if we have a quantity times another quantity and they involve square roots. Really, this is all multiplication because if there is a constant out in front of the square root symbol, that's implied multiplication. So the commutative property says, you know what, I can totally rearrange this, and I can rearrange this a and the c. So a times c times the square root of b times the square root of d. And then I can multiply these together. So the easiest way to think of that is if there is a number outside the radical, you can multiply them together. If there are numbers underneath the square root, and if you happen to be in the future working with cube roots or fourth roots or fifth roots, they do have to be identical in order to multiply underneath the square root. So let's look at an example here. Here I have 2 square root of 3 times 5 times the square root of 6. Okay, what I can do is I can actually think of this as 2 times 5. So here's my 2 and the 5 times the square root of 3 times the square root of 6. And I can simplify that to 10 times the square root of 18. Now I'm not done yet because if I can simplify a square root, I need to. So I'm going to rewrite that as the square root of 9 times the square root of 2. And move my paper down. And so that's going to give me 10 times, now the square root of 9 becomes 3, and then I still have the square root of 2. So all of this simplifies to 30 square root 2. So here's our second example. And I'm going to go ahead and highlight. We have a 4 and we have a 5 that's out in front of the parentheses. So I can just go ahead and multiply 4 times 5 and get 20. Now underneath the square root, I have a 2x and a 6x. So I'm going to go ahead and multiply those together, and that gives me a 12x squared. All right, now all I have to do is simplify that square root. So I still have a 20 out front. Underneath that 12, I can divide that up into 4 times 3. So that gives me a perfect square right there. And x squared is a perfect square, or you can think of it as x times x, and that's a pair of x's that are going to come out. So I have 20 times, all right, the 4 is going to come out. That means we're going to actually take the square root of 4, which becomes 2. We have a pair of x's that are going to come out as an x, and I am left with only a square root of 3. So let's go ahead and simplify all this, and I get 40x square root of 3. Looking at our next example, here we're going to multiply a monomial times a binomial, and it works the exact same way. We're going to simply distribute, only this time we're distributing with a square root. So square root of 5 times 2, well, the 2 is not underneath the square root, so it cannot multiply with the 5. So I'm just going to write that as 2 square root of 5. And then if I distribute again, I get the square root of 5 times the square root of 5. And so I multiply the 5 and the 5 to get 25. And now let's simplify. The first term, 2 square root of 5, that cannot simplify. The second term simplifies to simply a 5. All right, so that was multiplication. Now we're going to go on to adding with radicals, or in this case, simply square roots. All right, when you are adding radical expressions in which the radicand are the same can be added in the same way that monomials are added. So here's what you're used to when we say combining like terms that we call monomials. A 2x plus a 7x, you add, or you combine like terms by adding the coefficients, and that would give you 9x. Well, for radical expressions, the radicand has to be the same. So the radicand is the square root. So the square root of 11 and the square root of 11. If those are identical, then you do the same thing. You add the numbers out front. So 2 plus 7 gives me 9, and I do not change the radicand. It's still the square root of 11. So when you start adding or even subtracting square roots, you do have to look at the radicands and decide, are they alike? If they're not alike, you cannot combine them by adding or subtracting. So I'm going to let you give this one a try on your own, and let's see what you come up with for your answer. These are all like radicands because I have the square root of 5 plus the square root of 5 minus the square root of 5. So I get a 6 plus a 1. So remember there's that ghost 1 minus a 5. So I'm going to add those numbers and multiply by the square root of 5. So adding those together, I get 2 square root of 5. All right, let's get another example. In which the expressions, when they're given to us, don't appear to be like radicals. However, we have the square root of 12 and the square root of 75. And I realize that those square roots can be simplified. So if we can, let's go ahead and simplify them and see if that makes a difference here. So I'm going to change the square root of 12 to the square root of 4 times 3. And the square root of 75, I'm going to break that into 25 times 3. All right, let's simplify here. This 4 is going to come out as a 2, so I get 3 times 2, square root of 3, plus 5. Now the square root of 5 is going to come out as a 5, and I still have the square root of 3. So that gives me 6 square root of 3 plus 25 square root of 3. Hey, look what happens. We end up with like radicals, or radicands here. So in this case, we can combine these. We're going to add the 6 and the 2 together. So if I add the 6 and the 25 together, 6 and 25 give me 31. And my radicand remains the same. So I get 31 square root 3. All right, here's one for you to try. Answer it as a quiz question, and then check your answer. So let's start by simplifying. I get 4, and 8 simplifies to 4 times 2, minus 2. 50 can break into 25 times 2. All right, so I'm going to end up with 4 times this 4 comes out. Square root of 4 is 2 times the square root of 2, minus 2. Now the square root of 25 is 5, so that becomes a 5 with the square root of 2. And if I keep simplifying, I get 8 square root of 2 minus 10 square root of 2. And we do have like radicals, so my final answer is going to be negative 2 times the square root of 2.